on the whiteboard. So
Yeah, okay, that
but we don't know what the average is. We measured the amount of water loss each day for the aquaponics system in the student experimental farm. And the way that we did this is we measured how much water we put into the system. So we graphed the total water that we used, which was the total amount of water that we put in over the course of about 3 weeks. And the way that we did this is we took the amount of water that we added that day and we added it up with the total amount of water that we added every day before that. And we came up with this nice little linear relationship between the amount of water that we used and time. And what we were able to find was that by applying a best fit line, we used an average of 12 gallons per day. So that is the average water use of Zion aquaponics system in the student experimental farm. So this is the actual data measurements that we got from the farm. We measured the temperature inside the greenhouse, which are these green dots, and the outside temperature, which are these yellow dots, and the amount of water that we added that day, which are these blue dots down here. And as you can see, they're really all over the place. And part of the reason why the blue dots are all over the place is because we couldn't take consistent measurements of the water because no one had time to go up there at the same exact time every day for 3 weeks because, you know, we have lives. So we have here a graph that looks more or less like 3 stock charts put together. And if you go down here, it's pretty much the same temperature, same thing with humidity. We have water here graphed against humidity. We took humidity values, and there does not really appear to be a correlation. And we tried to see if there was a correlation between water loss and temperature. So I divided the water loss over the number of days that we weren't there, and tried to graph it against temperature to see if that would help. It didn't. This is, again, the water data is all over the place. And there does not appear to be any correlation between the average water loss and the temperature or the humidity. So if we were to do this experiment again, one thing we would probably do is stick to a strict regime of checking the water and the temperature regularly in order to get a valid set of data for which we could find a correlation between the temperature and the water loss. From this calculation, how much energy will it take to evaporate all of the water that we calculated that we added to the aquaponics system? And secondly, how much of the energy of Earth would the embodied mass energy of this water supply?
Aquaponics is a very young club. The significance of this experiment to it is that we're creating an ongoing experiment to measure water loss in the future. Aquaponics is to heavy agriculture as railroads are to the Hyperloop. It signifies a paradigm shift in culture in the manner in which we produce our food. So this experiment will be a great value to this club and aquaponics as a whole.
At every point.